Hi everyone, my name is Romeo Rodani and I'm a solution architect at Thomson Reuters. In this Dash session, I will talk about Thomson Reuters' journey to the AWS cloud while the company was literally split in half and how we had to deal with a large-scale cloud migration in the face of data center evictions. But before I would get into that, let me tell a bit about Thomson Reuters in case you wouldn't be familiar with what we do. If you haven't heard of Thomson Reuters, we provide news, information, and tools to the legal, tax and accounting, compliance, government, and media markets. I myself work in a centralized group within Thomson Reuters called Infrastructure, Hostings and Networks, or IHN for short, where we help and work with all of our lines of businesses to come up with cloud best practices, cloud tooling, and strategy for getting to the cloud. And we also provide a number of shared services to those businesses, like a landing zone and management of hundreds of cloud accounts, networking across the enterprise, operational support, incident response, and more. So now that you know about Thomson Reuters and what we do, you can imagine the wide variety of products we host in the cloud. And we started that journey not with a forced mass migration, but rather a choice and decision on an enterprise level back in 2015. From that onwards, we gave up on our private cloud efforts and started to focus completely on public cloud. And all the new greenfield projects were started to be deployed into either AWS or Azure. We created a cloud center of excellence. We pushed people to get the most out of cloud services, use infrastructure as code, use containers or serverless. And we spent a ton of time with cost optimization and security. We also designed a multi-account strategy and landing zone to eliminate the burdens for each project, so teams need to worry less about identity and access management, VPC designs, networking, IP ranges, and the IP space, direct connect, and connections back to the on-premise data centers. But then we divested our largest business segments, the finance and risk business unit in 2018, which is now called Refinitiv, and effectively splitting the company in half. The split then led us into forcing us to rethink our cloud strategy and the landing zone structure, and also led into thinking about what do we do about all the applications that we run in the divested company's data centers and how we move them to the cloud. So this is the story I will tell you today. To set up the challenge with these applications that were running in our divested company's data center, we started out by creating TSAs, or transitional service agreements. We had 2 years contractually to keep those dependencies on each other before we had to completely separate. The application scope was around 411 applications and 10,000 plus servers. In addition to splitting the landing zones, the teams got split too. Teams like our Cloud Center of Excellence and Data Center Operation teams. So we had less people to do the same work. At this point, we took the opportunity to merge the Data Center Operation teams and Cloud Center of Excellence teams. Merging them led to flexible resources to adapt to migration needs. Now back to how we solved it. When we looked at the holistic problem, re-architecting 411 applications to fully cloud native was not in scope. We had to look at a different strategy. We knew we had to accelerate our migration. We knew we had to empower teams to do those migrations. Monolithic waterfall model wouldn't work for a program of this size. We needed to operate in a more iterative and agile way to be successful. In the data center, we had around 170 services that our operation teams used to manage our infrastructure, which were also dramatically different in the cloud. I'm talking about all the tools we use for monitoring, alerting, security, intrusion detection, source code management, or artifact management. There was also a culture shift that was required. Tinkering was fine, but the key message from the program was to migrate first to the cloud and then modernize later. We wanted to avoid the distraction of this migration and had to maintain service levels to our customers. At the end of the day, we really need to answer this one question. How do we migrate quickly, stay security neutral or better, and not take some of our legacy proprietary technologies with us to the cloud? For a company with our size, we had a ton of teams with different cloud expertise, but we needed a default answer and strategy, so we built a framework around Gartner's 5 R's cloud migration framework. We were familiar with cloud-native approaches like rebuild, revise, as we have built a number of solutions using serverless technologies like Lambda or container-based solutions like ECS, EKS, or other managed services like Step Function, API Gateway, Aurora, and so on. But for this particular exercise, we needed more clarity around cloud-ready approaches, as we could not spend time to get the whole company to re-architect and rebuild their solutions. We got a ton of advice to do a bit-for-bit migration and to do VM to VM based lift and shift. But we quickly realized that it won't fly, as we had a wide variety of systems and also had many with way too old legacy solutions using Windows 2003 or 2008, for example, which are not even supported in the public cloud anymore. If you have been running your own data center for a number of years, I'm sure you can relate. We also had a ton of file shares and Windows share storage, which wouldn't really play nicely if you were to just export and then import the VM into AWS. Not to mention all the on-premise load balancers where we used F5s and the wide IP logic we had in place, which would have needed to be migrated with the servers. So although rehosting looked appealing at first, in reality, it really didn't work out for us, and we rather laid down some fundamental guiding principles and rules around how we want to do minimal viable refactoring. So update the operating system versions to the latest. Use cloud-native load balancers like application load balancer, network load balancer. Look at each individual third-party licenses and evaluate whether we can replace that with a cloud-native offering, or it has to be repurchased with a different cloud-native version. Migrate off the current monitoring tools and use Datadog on every single host. All these ground rules had a ton of benefits in terms of our security posture as well, like migrating to a new operating system version and having consistency across our cloud real estate makes it so much easier to support and operate the applications and manage the migration. Also, it consolidated the number of different OS versions we had. One thing to keep in mind that dealing with refactor and or rehost had a fundamental impact on the skill set our staff required to have. But I will talk about that later. To accelerate even more, we made a number of significant changes around people, processes, and technology. We started with people and finding the right partners. We created various new processes to streamline migration approaches for each given app. Created and used new tools and services and focused a lot on automation. So when I said we started with people, what did I mean by that? Well, we did our best to enable our application owners to deliver on their given timelines. We did this with organizational change and program changes. We all love to think that organizations shouldn't matter and we can all work across teams to reach a goal. But for this big of a program, consolidating those two teams, so the data center operation and cloud center of excellence, was crucial. This enabled us to pull in the right set of people with the right set of skills whenever we needed them. And we avoided difficult conversation around resourcing. It also allowed some of our employees to upskill and get involved with cloud projects. A project of this size, with a company that was just cut in half and literally halving our teams, was not possible without viable partners. So we actually engaged partners like EPAM, TCS, Deloitte, Capgemini, AWS ProServe to get more resources, but also worked very closely with AWS and their AMS or Amazon Managed Services team, who helped us tremendously and gave us a brand new landing zone for all the applications that were to go through a migration. They helped with the day-to-day infrastructure management. They got a full change management process. They also help with cost optimization, patch management, and so on. Imagine it as AWS providing you a proven enterprise operating model and platform to migrate to. We didn't just get help and consultancy on a high level from these partners, but also resources and staff augmentation to make sure we got the right skill set across the board. We also ensured that we used those highly skilled individuals in a viable way. So on a program level, we also ensure that SMEs, both internal and external, with significant cloud skills are embedded and used throughout the project. On the program change side, we started with a very centralized view on this. At first, we wanted to keep application teams working on their products and not distracting them with lower business value exercises. like doing a migration, which ultimately doesn't immediately bring any benefits to our customer. We created a central team to do migration. We called it a migration factory. But we very quickly saw that this just won't work. We moved from a central to a more distributed model. And we didn't just do that by saying, hey, it's your job, but we give the app owners support, resources, and manpower. We give them technologies, automation, and we give them training. A lot of these teams haven't seen cloud yet. So we established a training path to bring anyone up to speed. Everyone involved in the project had to know what AMS is and how to work within it, and what is TR's cloud strategy. We also knew we needed a central leadership function, so we set up a central steering committee. The steering committee made sure we kept on marching in the same direction, also ensured we had a clear escalation point, which helped to avoid treating every application as a priority one migration task. So one of the best lessons we learned from everything I previously mentioned is that enabling people is key for a migration to succeed. There is no single cloud service or capability that could have migrated all of the workloads into the cloud without our people being involved. So once we empowered our people, we needed to give them processes and tools to further enable their success. We developed several new processes focused on discovery, creation of patterns, processes for the actual migration, and for post-migration operations. One thing we definitely learned throughout the creation and various iterations of these processes that you should never wait for a finalized process, as it has to change over time. So the first process we had to come up with was around discovery. We already had a process for discovery for cloud-native projects, but we needed a new one for cloud-ready. We went through each one of our applications that was hosted in the divested segments data center and looked at what technologies, what third parties it used, how many servers, how many databases, what kind of licenses did it have, what was its architecture like, all the normal discovery stuff actually. Then based on all that information, the SME or solution architects like myself came up with a plan and figured out what is the migration plan and implementation pattern for that particular application that could work. Which cloud provider should this go into? How could we avoid redesigning the application completely around serverless, which was certainly tempting? We did this by scaling up our centralized solution architecture team, which worked with each application team that had something in the data center. This helped preventing delays for teams that had no cloud experience, as we partnered with them. Also helped with their training and focusing on the relevant AWS service to learn and use. It was critical, though, to only change what we absolutely had to, like load balancers, or explain the ephemeral nature of the cloud and the importance of the use of multiple availability zones or security groups. This brings us to the next lesson learned. Anything you miss in discovery will slow you down in the migration later, but it's also important to acknowledge that discovery is never perfect. There were cases where servers were left out, or some dependencies at the code level to another application or third party that no one remembered. Plan for wrong information and also plan for iterating on the process. Throughout the discovery process, we also discovered a number of patterns. Application and products that use technology have a finite list of what they use and how those resources are organized. Like, for example, we had a ton of two-tier web application with an F5 load balancer in front of simple web servers running Apache or Tomcat or something similar, and then a database on either MS SQL or Oracle, all of which could easily be turned into a pattern that then can be reused if another similar application comes up in the migration roadmap. So we developed the process to realize, document, and share these patterns across the organization. We built our own migration pattern library that is available to anyone across TR. These patterns were often implemented by central teams, so who supported the database in the data centers now transitioned to support databases in the cloud. But like every central team, it can easily become a bottleneck if a lot of app teams rely on them. So there is a lessons learned here too, that transparency is key for developing patterns. It sounds super obvious, but when you are in the thick of a migration and you are pushed for time, documenting patterns and work items and linking dependencies is not at the top of your mind. and we really suffered because of that. The way we suffered is that the application teams knew they needed a database, and they knew who was building it. So they went straight to the developer asking for status updates. That meant that the developers were constantly distracted and worried about timelines. So once we stopped and we get organized to visualize the dependencies and align them with application migration dates, the chaos settled. Over time, these patterns became a massive success as they reduced the time we needed to spend with discovery and solutioning around how to refactor a particular application. We developed a bunch of patterns around databases and load balancers, file storage and file shares, and even around our firewall strategy using security groups. And when a new application came along, we just knew, hey, this application needs yet another highly available, multi-availability zone, MS SQL database cluster. And then the team easily built one for the application owner. Equally as important as discovery and patterns is the operational processes. It's not something application teams will care for, but it's crucial. App teams also might not know what needs to happen to operationalize their solutions in the cloud, especially not early on. Like how to deal with an EC2 instance failure, or loss of an AZ, or what to do with a certain CloudWatch metric, and many services like load balancers. We also had to change a lot around how we did patching and support compared to how we did it on-premise. Consistent tagging became crucial as we had to use that to drive maintenance windows and cost savings. Given we had a ton of pet instances and mostly oversized instances for safety, we even used AWS Instance Scheduler to start and stop instances for lower environments to save costs. There is also a massive shift in terms of the ITSM mindset. In a data center and on-prem, you would have every single switch, router, VM, and their dependencies mapped out, put into a CMDB solution, and ServiceNow. But in the cloud, that's very different. A VM that you have today might not be there tomorrow, just simply because of a scaling logic or availability zone failure. These configuration items, which were servers before, became a cloud application. A ton of mapping had to be done, and also had to train the teams to deal with this. We also leveraged a ton of third parties to make this shift to cloud-based tools simpler, for example, using Datadog for monitoring and alerting. We also introduced game days to prepare our operation teams, not just for incidents, but also to ensure they have sufficient knowledge on how to operate in the cloud. I had to stress that training prior to game days is super important. We had a number of cases where it didn't happen, and the game day wasn't as useful as it should have been for the teams. So we knew our migration process had to follow our discovery processes. It had to be very distributed. Initially, it took way longer to get people work on migration tasks, as we treated them as business as usual, and product features always outweigh the migration activity. And that's why we had to come up with a different model, which we call the Cohort Model, where we literally got some of our partners' experts and our own solution architects, application developers, app owners, and the supporting engineer in the same room to work on a set of application migrations in a given BU's portfolio for a week or more. Like, for example, I was in multiple cohorts where we spent weeks to migrate Reuters editorial tools, all of which were interconnected and made sense to do it all together. Being part of these, I can safely say we saved a tremendous amount of time by being in the same room. There were hiccups, as with everything at first, but once we got into the rhythm, everyone knew what to do and how to turn a migration plan, an AWS diagram, into infrastructure, and what are the biggest problems to think about. Like the application deployment itself. Building infrastructure is easy. A bunch of EC2 instance and load balancers here and there, but making a legacy app, which no one knows how it works anymore because the developer left like 5-10 years ago, and now it has to run on the latest operating system in a cloud environment on ephemeral hardware. Now that is hard to solve and requires synergy, efficient collaboration, and more. We learned the hard way though that setting up prerequisites like the infrastructure, networking, routing is best to be done before the cohort itself to save time when the team is in the room. Also, having key people like network engineers and the DB team on Lifeline, so ready in case we need them, was also very important. So once we established these ways of working, then we looked at how can we accelerate the migration even more? How could we speed up the process to get discovery information and plans converted into infrastructure? We noticed it very early on that creating infrastructure took weeks. We looked at the calendar and we realized this wasn't going to be enough. We needed to move faster. Some delays occurred because of the lack of prior experience with AMS, or people being too familiar with a cloud-native approach and not with AMS. So it was also caused because of the lack of knowledge with some of our existing applications. And then the landing zone creation was also a bottleneck, as it had to be created by the user and then handed over to AWS to manage it. AMS also used a very robust change request process where every single change, even if you just swapped out a single EC2 instance or made a configuration change on that EC2 instance, had to result in an RFC, or request for change, which is really an API call that can be done manually or via submitting a CloudFormation stack. And then it gets reviewed by AWS for compliance and security reasons. This was a new way of working for all of us and came with its own set of challenges and latency. But AMS was a great partner and listened to our continuous feedback. Hence, they released a feature called the developer mode, which enabled us to make rapid changes throughout the cohorts, for example. It also added new features based on our request and made the landing zone creation exponentially faster. And it also enabled us to start thinking more about automation in all other areas as well. So we created a framework to seamlessly move from discovery and plans to infrastructure creation. It was a framework built using Troposphere, a Python framework for generating CloudFormation, to automate the process and basically the previously mentioned RFC, or request for change creation. The goal was to minimize the changes to our input files for each of the apps, because that meant time savings for each migration and reusability across the enterprise for various portfolios or apps. This tool also helped with the creation of resources, as given most of our apps would just use EC2 instances with an instance profile to get configs from like the secret manager, for example, and some encrypted EBS volumes. And then also EC2 instances obviously needed security groups and load balancers for default multi-availability zone resiliency. And in most cases, we also needed entries in Route 53 to manage live standby failovers, which is a traditional approach in data centers. So this framework really worked out for us, as it automated the steps involved in creating these core components for an application. We could also automate the mundane, but still very important tasks like tagging, which was required for better visibility in our ITSM processes, but also for maintenance windows and cost savings. This framework covered 90% of our use cases, so it was a huge success. So although we had a diverse set of capabilities and applications, we found consistency for infrastructure creation. And then we also used automation for application deployment. There were a number of apps which we didn't deploy that often, maybe once a year or even less. For those, we didn't spend too much time on the automation. But for the ones where deployments were more consistent, we looked at automation. So this was a very interesting one, as we used cloud-native AWS accounts and its services like code pipeline, code build, code deploy to pull code from Git, use S3 to store our configuration and deployment files with also the artifacts, then use various cross-account and assumed roles to create change requests and to invoke deployments into the Amazon Managed Service account. So this model enabled us to both test rapidly in a cloud-native account, but also to build on the top of our infrastructure we created using the custom Troposphere framework. It also supported multiple accounts, used the standard code build, code deploy config files, and supported multiple deployment types. It was another piece of automation that enabled our success. So with all these processes, organizational changes and program changes, great partners, tremendous amount of automation and work involved, we finished our application migration on the 26th of June, way before the deadline, all within budget. And now we are completely focusing on modernizing our apps to move them to more cloud-native solutions. So currently, we are actively running more advanced training sessions and workshops for the teams to get them familiar with microservices-based architecture, serverless solutions, AI, ML, and just in general on how to move out of AMS into cloud native, so default AWS accounts. Obviously, mainly for cost savings, but not with the same urgency we had during the split. I'm not going to go through all the lessons learned here once again. This is really for everyone to take home and use in your own time, in case you would also need to go through a similar effort. Although I'm sure you would have a different journey. I can definitely say though, that looking back at this project, no one really knew how we're going to do this within this time frame. All we knew is that we had to do it, as otherwise we would have been financially penalized, but we were all enabled and incentivized to succeed. The fact that everyone was open to feedback and suggestions cemented our success. So the only takeaway I really want to emphasize once again is to enable your teams and people and find the right partners, and then you will be successful with your own migration. And with that, this concludes my session, and thank you for listening. And now let's go to questions.